the bottleneck's not typing. The bottleneck is not code production. The bottleneck is thinking and understanding and trying to do the right thing. And that, in terms of a bottleneck, is not going to be made any slower by doing TDD. If you don't know how to do TDD, it will be slower. If you think the week that I've got crunch time in order to get something out, in order to not get fired, that is not the time to learn TDD. This is a bad time to learn TDD. Don't start doing TDD that week. But if you do know how to do TDD, it is no slower, and it may be faster, because as I say, it's a thinking tool. It's a way of leveraging a test in order to think harder about your code and the right way to write it. That's when it might be better.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. This episode is brought to you by our friends at Cockroach Labs, the makers of CockroachDB, the most highly evolved database on the planet. With CockroachDB, you can scale fast, survive anything, and thrive everywhere. It's open source, Postgres wire compatible, and Kubernetes friendly, which means you can launch and run it anywhere. For those who need more, you can build and scale fast with Cockroach Cloud, which is CockroachDB hosted as a service. It's the simplest way to deploy CockroachDB and is available instantly on AWS and Google Cloud. With Cockroach Cloud, a team of world-class SREs maintains and manages your database infrastructure so you can focus less on ops and more on code. Get started for free with a 30-day free trial or try their new forever free tier that's super generous. Head to cockroachlabs.com/changelog to learn more. Again, cockroachlabs.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Join 7,300 of your fellow Gophers and follow Go Time FM on Twitter. We post highlights from past episodes, links to interesting projects and repos, notifications for the live show, and of course, those oh so popular unpopular opinion polls. Once again, we are at Go Time FM. Follow along. Okay, let's get into it. Here we go.
Hello, welcome to Go Time. I'm Matt Ryer, and today we're talking about test-driven development. Yes, that strange process where we write our tests before we test the thing before it even exists. What are we playing at? Well, we're going to find out today. And joining me, welcome back, Chris James. Hello, Chris.
Hello, Matt. Thanks for having me again.
Oh, always a pleasure.
Well, it's twice now, so 2 times.
Both times it's been a pleasure.
Yeah. Well, we're assuming this one's pleasurable. It might not be.
Good point.
I guess we'll see.
One time it was a pleasure, and the other one, we'll see.
Yeah.
Thanks. That was kind of like a test-driven development little... I feel like I failed the test a lot of times, but we got there in the end.
Yeah, well, after the show, we'll all appreciate the joy of seeing a failing test. So
yeah, of course.
Fine.
That's it. We'll find out why. Joining us also, it's only David Wicks. Hello, Dave.
Hello. Hello, Matt. How you doing?
Welcome to Go Time.
Thank you very much. Very pleased to be here.
Great to have you here. And don't worry,
Exciting.
it's not just us. We have another special guest. Ria Dutani is also here. Hello, Ria.
Hello, how are you?
Good. Welcome to Go Time.
Thank you. Thank you for having me.
You're very welcome. And I've got some intros for you all here, which I'm going to read now. Dave is a former academic philosopher and local librarian. A terrible marketing guy, and now a web developer and occasional contributor to Learn Go with tests. Interesting. We also have Chris, who's a former engineering manager, now fun-employed. And you wrote that, didn't you? Learn Go with tests.
Yeah, it's an ongoing project, though, so it's both a past and future tense.
Yeah, it's a difficult one to handle for me. And Ria, you have a background in economics and tax disputes, right? And now you're a software developer, newbie, you say, and a teaching assistant. That's cool.
Yeah, so I've just been a software developer for, I'd say, like 2 years now. And so I still count myself as a newbie, although I think I'll be a newbie for like the next 20 years or something. And yeah, on Sundays, I teach disadvantaged people how to code. So people of color or women or refugees. So yeah, it's fun.
Brilliant. Wow. Well, that's great. Oh, you're putting me to shame because I spend my Sundays doing nothing. What is TDD? We need to start here because this is strange. And I know when I first heard of this concept, it just sounded like it didn't make any sense. What is it? What do we actually mean by test-driven development?
Well, I mean, the brutal, if you like, simple version is it's a process, in a way, where you will start before you've written any code by writing a test. This is super high level, right? We can get more into it in a bit. Writing a test that describes some aspect of the system you want to build. And then, when you've written that test, and you might spend some time doing that, you will write the code that makes the test pass. Sounds a bit weird, but that's it. And then after you've done both of those two steps, you will finally go back and look at maybe the test code and the production code and refactor them, change them to make them in some way better, or loosely some way better. And I think, very often we call that red-green refactor. Red, the test is failing, you've written a test, it fails. Green, the test is passing, I have written code to make the test pass. And then refactor, fix everything. So that is like your super high-level, zoomed-out, beginner's notes version of TDD.
Brilliant, yeah. Now, in the real world, you can't really do this, can you? Like, if I was going to make a bicycle and I got Chris to test it, and I was like, right, Chris, can you test this bicycle? And he just has to kind of walk around funny because there's no bicycle yet. You can't really test it until I've built something. That's not true for software, though, is it, Chris?
No, I think it works in the real world because, well, for one, we're working in the abstract anyway, so we're not in the physical world because we're writing code. So, the rules are a little bit more relaxed than the physical world. But the fact that the test doesn't work at first is the point. What you're trying to do is, rather than diving into building lots of fancy code and abstractions and things, your first objective is to figure out what you're trying to build. And that's surprisingly, or maybe not surprisingly to some, a thing that people get wrong a lot of the time. And what I think TDD gives you in this first step is this kind of method it adds discipline to the way you work. It makes you concentrate on trying to accomplish one thing. And by giving yourself this kind of like North Star of what you're trying to accomplish, in theory, or what people who like TDD would say is that gives you a better chance of success.
Yeah, that's interesting. You mentioned that the test failing is kind of important in the beginning. Why is it important that a test fails first?
Because I think we've all been in places where we've written a test and then we kind of go along our happy way. And then we later realize that this test never fails. It's called like an evergreen test where you haven't actually verified that the test fails the way you expect it to fail. And if you don't do this step, not only do you have these tests that don't actually fail for the reason you expect, but it often means that you've left some assumptions on the table. You maybe haven't quite understood the problem as well as you should have. What's great about writing a test first is computers don't deal with ambiguity. You have to be very precise about what you're going to do next. So again, that's the reason you want to really make sure that the thing you've specified is correct. You want to exercise that test and make sure it fails how you'd expect.
Yeah. So you're saying something important if it's failing and then it's later not failing. Then you've impacted some change.
Yeah, you've got to have some sort of engagement with the world. You've got to feel that, I'm changing something. We tend to like green stuff better because we're human, but it's the red that's important.
Yeah.
Yeah, and I think like later on, when the test fails for some other reason, if you have a useful message, it's easier to act upon it as well. So when you see that, red test and the message telling you, hey, you've done this and this wrong, it's really clear and explicit. So in the future, you can quickly understand what you need to fix.
Yeah, so that's nice then. One of the side effects is you end up with a suite of tests that really they're saying something about your program. And then if you do something which has some unexpected side effect, which happens all the time, in the most unexpected ways, doesn't it? You then get that feedback from your test suite so it can help you. That's really valuable. But I suppose people get that by writing unit tests after the fact. What's the benefit of kind of writing the tests before? Is there a benefit, or is it okay to just write your program and get it working and then just add some unit tests after?
Well, the thing that people get wrong with test-driven development is they think it's about tests. It's in the title, right? You know, test-driven. You think it's going to be about tests. But if you think test-driven development's like all about tests, it's almost like thinking astronomy is all about telescopes, right? The tests are a tool. They are not what this ball game's all about. You're going to be using tests, you're going to be writing them, but the side effect of having a nice set of suites and test suites and being confident in your code, it's great, don't get me wrong, it's a nice thing, but that's like this much of the story. The story I prefer to tell about test-driven development is this is a tool to help you design software. It doesn't magically design software for you, that's maybe another mistake people make, but it's a way of building software to allow the design for you to discover the design. It's a tool to let you think about the design of your software, rather than a sort of, a thing about tests, that's what it's not, or a thing that magically creates a design. It's also not that. So yeah, let's think about that. It's a tool to help you design software.
Yeah, that is a nice point, because one of the criticisms you hear about TDD is that you end up writing weird code in order to make it testable. But in my experience, that's only led to better code. I've never looked back and thought, I wish I didn't have to test this code, but then I could write it in a different way that was better or something.
Yes.
Yeah, the way I like to look at it is related to this is this whole idea of top down and bottom up with TDD. TDD doesn't say that you have to do one or the other, to be clear, but I think TDD is simpler to practice from the top down. And the reason for that is that really the tests you should be writing should be very consumer focused. Now, consumer focus is also quite difficult to pin down. Like, do you mean a consumer of an API? Do you mean a consumer of a user clicking around on a website? That can be quite hard to pin down. But by driving from the top down, it means that your tests really should read as if it was being called by a consumer. And in that respect, you tend to not have these kind of strange looking tests. Generally, you'll have tests that express the truth in terms of, when I call this thing, this useful behavior comes out. And again, this idea of behavior is very important with TDD as well. It's this idea of, we don't want our tests to be coupled to sort of implementation detail, because implementation detail is something we want to be able to change freely. We don't want our tests locking us down. And I've certainly been in projects where we feel like we're doing a really good job. We've written tons of unit tests. We've got amazing, incredible coverage and things. But then at the same time, we're all like, but I don't really want to refactor that because I'm going to have to change half a dozen tests. So we'll just leave the code. We'll leave that tire fire as is. And I think that comes again from this angle of maybe going bottom up and trying to test your design, rather than thinking about it in terms of, what does the consumer want? Because when you pin down what a consumer wants, that helps guide your design a bit better. Because rather than kind of imagining all of these abstractions and all of these designs and interfaces and all this malarkey, instead you're just thinking, what is this? We got a single goal and I've pinned it down precisely because I've got it written down in code. It's not just like some words in Jira or whatever. I've got it really precisely defined. Now what is the design I need to accomplish that? And that means, again, it's this idea of discipline to writing your software, not being overly imaginative and things. It's not trying to suck the fun out of software development entirely, but I think a lot of the time developers can be a bit guilty of diving in a bit too quickly and not really sort of slowing down and thinking about what they're trying to achieve.
Interesting. Ria, you're perhaps the one that came across this concept more recently than the rest of us. And so how was it when you first encountered this idea? What was your experience with it and what did you think of it?
So what's interesting is I learned how to develop through a software bootcamp. And luckily, the bootcamp that I went to taught us how to do TDD. So in my experience, I've always known about it. And I've always thought, yes, testing is, part of software development. How could it not be? So from my approach, I think testing is important, but I would say that I didn't really understand why, in the sense I knew that you should do it, but I didn't really grasp the importance of it or how it would help me design code until I started doing it a lot more, like in my job. And so from my perspective, when I was doing something that's real, so writing software for a company, I think I would get really confused when I saw, a Jira ticket at the beginning. And I was like, oh yeah, I know how to do this through code. I can just write this and this and it would make it pass. But the test made me break it down into smaller chunks. And that's when I really started understanding how it would help design, because thinking of it in a modular way just made me think about just that one problem at a time, that one behavior. So I think it was only later on did I really, grasp that importance of TDD.
Yeah, it's funny. We talk about like, you get to really also be like the first user of your code, don't you? And so if you think about like, hopefully we know that user experience is important if you're building a product, or if you say if you're building a website, the end user experience is very important. We don't always apply that to our code and our APIs and things, but it is important because these APIs are used by people, aren't they? They're the first users of that are the people. Obviously, at runtime, it's machines talking to each other, but there is a human there. So, yeah, what's the benefit then of like being your own first customer? Does it change the way that your APIs end up looking?
I think it can change the way an API looks. It can. I mean, I'm not going to suggest it, some people can't just roll it off the bat themselves without TDDing it and going that way. I think for me, it starts with that failing test you're writing. You should be thinking, imagine this beautiful world you live in where you've got the thing that does the thing that you want it to do. When you're using it, you don't want to be calling 8 different things, 5 methods there to get to the answer you want. You basically want, give me the thing I want as a method or a function. That's it. The magic box that does the thing you want. And then by writing that in the test to begin with, just saying, this is what I, as a person, want to be getting out of this, as a consumer, want to get out of this. You're then led through a nice API because, yes, you are. As you said, you're the first consumer of the API. Those tests are the first consumer of the API. They document the API quite nicely. API, not just in terms of, to be clear, API in terms of, say, an objects interface or a functions, the way a function works. We're not just talking in terms of HTTP APIs, which people often think about. Yeah.
Yeah, good point. Yeah, we mean any kind of code that you're going to consume. Any kind of interface, yeah. Yeah, and it is a user interface, isn't it, really? Yeah, so when we talked about the red-green refactor thing, how strictly do you do that? Because if you stick to it very strictly, you basically have errors to start with because you're calling methods or you're using objects that just don't exist. And in a way, it's nice because you get a kind of to-do list laid out for you. You try and run the tests. It doesn't build, so you get errors. And really, all you have to do is make those errors pass, and you'll progress it in some way. How strictly do you do that? Do you tend to write a bit of code at the same time, or what's your process?
I think this is one of these things where, I definitely want to sit here and say I'm absolutely strict all the time. But honestly, I think the more I've done TDD, the more I've appreciated the importance of being strict with it. I think people, when they learn TDD, they'll read some post about it, right? And they'll follow the process and they'll go through it and go, all right, yeah, I get it. It's getting a bit tedious now. And, and maybe they'll skip a few steps or whatever. And they're thinking they're too smart for it. But more often than not, that kind of ends up tripping you up and you start making these mistakes. And unfortunately, some of these mistakes don't become apparent until later. For instance, this idea of these evergreen tests is a good example of that, where like if you don't exercise seeing the test failure, that's the sort of thing that will bite you in the bum. In 3 months' time, when you've lost all the context around it, and even worse, it might be one of your colleagues rather than yourself, so someone else is paying that price. The steps are there for a reason. They're there to make sure that you keep focused on the particular task at hand. Coming back to the red step, I just wanted to add to Dave's bit. Like, I think we were talking earlier about how we don't like the red state. We don't like seeing failing tests. But the way Dave was talking about it reminded me about how this is actually the chance to be optimistic about your code and actually be a bit more sort of idealistic and write the tests you want to see. And I think that's a really nice step. The failing part is just a validation, right? It's not a personal attack on you. It's just, okay, it's failing how you'd expect. And then you get on to the next step. And again, I think it's really important on the next step that when we're making it pass, the strict part is making it only writing enough code to make that pass. And there's this really nice quote from Ken Beck's book about this. He says, commit whatever sins are necessary. And what he's saying here is like, you shouldn't be creative at this point. You're just trying to make the software work. Because at the moment, your tests are saying that your software doesn't work how you want it to work. So you want to get out of this red state as quickly as possible, because then you have the promise of the refactoring stage later. But you should only be doing this creative thought process and making things nice when you know the code works. If you're trying to make things nice and make the code work at the same time, you're doing two things at once. And software development is hard enough. And a thing I like about TDD is just trying to make it simple, really easy to understand steps that reduce the amount of sort of cognitive overhead that you have to go through when you're sort of writing software.
I agree with everything Chris has said. I would like to put out a word of warning in terms of following the process. Because we agree the following the process is important. Red, green, refactor. This can be terrible. This can be a terrible mistake sometimes. Because if you follow that process like it's a magic algorithm to spit code out, basically, I write my test like that, it's done, I write my code, next, refactor, well, I don't know, but I'll rename a few methods, write another test, write some more code, refactor, I don't know, maybe I'll change the name of a few more methods and add a comment. It doesn't work. Rich Hickey has a great line about TDD. I mean, I feel he misunderstands TDD, don't get me wrong, but he says it's basically like coding, like driving by hitting the guardrails, you know. Oh, that broke. Oh, that broke. Oh, that broke. I don't really know what I'm doing, but, I'm writing tests, so it must be working, and I must be making progress. This is wrong, right? If you're doing TDD like that, you're missing a trick. I'll put it like that. I don't think you're doing TDD very well if you're doing it like that. You should be looking at each stage and thinking carefully what's going on here when you're writing that failing test, right? Is the error message good? We've talked about that a lot. But the other thing is, what is this like now when I'm writing this failing test? Now I've got all these other tests in my wonderful test suite. Is it easy to write this next test? Is it hard? Am I now having to do some weird logical jumpy bits around? Am I having to endless helper methods in my test suite in order to get this test written? If you are, don't do that. Back out. You need now to go back to refactoring. I know, we just went from, writing a new test back to refactoring, but this is fine. You might need to do this sometimes. Refactoring your code to make that next test easier to write. And this idea that people have is something I hear when people don't like TDD, and it's okay not to like TDD, but it's usually a thing like, it doesn't lead to good design. It just leads to chaos. You end up with all these tightly coupled tests everywhere. And it's like, dude, this is not going to drive things for you. It's not a replacement for thinking and common sense. It's a tool. You got to use it. So that's that off my chest.
Yeah, no, that's a fair point. And yeah, that's right. Like, it's not an aimless thing. You're still responsible for designing your code. But I do find it helps me design better code.
This episode is brought to you by Linode. Gone are the days when Amazon Web Services was the only cloud provider in town. Linode stands tall to offer cloud computing developers trust, easily deploy cloud compute, storage, and networking in seconds with a full-featured API, CLI, and cloud manager with a user-friendly interface. Whether you're working on a personal project or managing your enterprise's infrastructure, Linode has the pricing, scale, and support you need to launch and scale in the cloud. Get started with $100 in free credit at linode.com/changelog. Again, linode.com/changelog.
We should talk a bit more about how test code can get tightly coupled with program code. How does that happen, and why is that worth avoiding, and how do we avoid it?
So I think that there are a few things. I mean, it's very hard to give a pithy answer to that.
Oh, don't then.
Okay, fine. We'll just move on. No.
Yeah, we only want pithy answers.
There are a few things that you can look out for. I think if you're happening to have mocks, which is everyone's favorite subject, there's nothing wrong with mocks or test doubles, but as with anything, if you use them too much or use them incorrectly, that can cause problems. Because one reason to use mock is to spy on something, right? You want to check that something happened within the internals of the thing you're testing. And sometimes you definitely need to do that because your thing has side effects and you're interested in those side effects. But you really need to think carefully about this kind of thing, because if you end up spying too much on your code, again, it comes to the point where if you want to then change the implementation details, you're going to end up having loads of failing mocks and all sorts of tedious kind of sort of changes that you're going to have to do to go through it. I think the other thing I would say is, again, I think you're less likely to have these kind of tests that are too coupled to implementation details if you start from the top. The problem with bottom-up development is you're not really using TDD at this point as a design tool. You're using TDD as a means of writing tests. And as Dave says, that's not really the point of it. And generally, if you're going bottom up, what you've done is you've imagined some kind of design. You figured out, I'm going to need a function to do this and a function to do that. Okay, I'm going to write some tests around all of that. But if your design isn't correct, you're going to end up again with this kind of problems of these tests becoming more of a hindrance than actually helping you.
Well, Like for me, when I'm writing a test, I like to keep it simple. And I think from like the top bottom approach, it's just nice when you have, say, like an acceptance test, and that's already focusing on something. And then you have a couple of unit tests for like something that, passes that acceptance test. And it's okay if that's failing, but it's already kind of like narrowing down what you need to do and trying to make it small. Obviously, you shouldn't write an acceptance test for every single thing, but having that approach is just easier to kind of make sure that you're not dealing with too many things at once. So that's how I try to look at it if I ever have to code something.
Yeah, I like that. It gives you something to focus on. It helps with that focus. Some people, even when they're writing code or working on something across many days, they will leave the state with a broken test, because when they come to it the next day, you know exactly what you need to do and you can sort of get straight back into the flow of it. And I do find that actually to be quite nice. Yeah. Any other tips like that?
Well, the acceptance test will, we're talking about, top-down TDD. The acceptance test will fail for a long time. You are going to start out there with this idea of the behavior of the whole system. You're not going to get to that, quickly. So that acceptance test, it may get committed and commented out or skipped, or whatever works for you in your testing framework or lack of a framework. Yeah, that's important. And yes, I find that works really, really well in terms of individual unit tests. If you end up at the end of the day thinking, oh, well, this is the next bit of behavior I would like to implement. This is the next thing I'll write. Yeah, put it in there, say what's going to happen, and get through. And Chris has got a hand up, so I think he's about to talk about behavior.
No, I was going to say, given this is a Go podcast, we're talking about TDD, but actually, I would personally recommend when you're doing Go and TDD, from a default position, use the external test package technique, where your tests have underscore test in their package name. And what that means is that they can only use exported members from the package it's testing. That has two benefits. One, again, it's this kind of idea of you see it from a consumer's point of view. I mean, in some cases, you can more or less copy and paste the test code and dump it into your own code, and it'll be basically the same usage. But secondly, it means that you can't reach into implementation detail within that Go package. So it just kind of stops that bad habit of testing unexported or private things, because going outside of the Go world, it's pretty much a given that people say you shouldn't test private methods if you're working in, say, an OO language and things. And the reason for that, again, you don't want your tests coupled to implementation detail. So that's the way in the Go world that you can protect yourself a bit from that kind of sort of anti-pattern.
Yeah. I like that too. And it's also like, even does silly things like you get to make sure that your API reads nicely. You remember that the package name is going to be used each time those types and methods and functions are called. So it's kind of nice that you get to be that customer again the first time. I do that if I can. I also find if I'm doing something that is hard, like, and by hard I mean like, say I'm just I've got some input data and I'm going to transform it or something that's quite difficult to keep in my mind. Having a test there, which I can just keep running as I'm writing and tweaking the code, that to me is just like, almost feels like a cheating way of coding. Like, I don't have to be good at coding to do that. I can just keep trying little things, do little experiments. And I find it catches off by one errors and things like that quite nicely. So I like that stuff. We've had some questions in our Go Time FM channel on Go for Slack. If you want to join the chat, then you can do so in there. Barnaby Salter asks, do you use Testify when writing your tests? Troll emoji. Do you? Bear in mind, I created Testify.
I believe is an improvement, right? That was the correct thing to say, right, Matt?
Yeah, thank you. I'll send you a $5.
The cool kids are all using is now, from what I can tell.
This is a difficult one because I'm a bit of a stickler for type safety. Mm-hmm. And the thing that kind of gives me an uncomfortable feeling with those things is that they all take interface, right?
Yeah.
In order to have a generalized assert equals function or whatever, it has to take interface, at least until we get generics. And I have been in situations where people have been confused because they see two things, like it prints out these two things are not equal, and you're looking at them, it's like, yeah, they are, but it's because like the two types are different somehow, but the string coming out is the same. So generally, I kind of don't use those things, but I don't think it's a big deal either way personally. I think it's just a matter of taste, really.
Yeah, I mean, as long as you're writing good test code, that's really what matters. Is, by the way, which is what I call it, testify off steroids. It does actually check the types. So if you pass in a float and an int and the wrong type, it will tell you that, yeah, these, although they're the same number, they are not the same. And I think Testify also does that too, although I don't know. There is some weirdness in Go where, because it's an interface, you pass in types and they're changed in that process, because an interface is kind of a type and a pointer to the data. So you're actually changing the things. And so that's a rare edge case.
So I was just going to say, what I mean was compile time check.
Right.
That's
yes,
what I was referring to. Basically,
Yeah,
I like to see red squiggles in my IDE
Yeah.
because they reassure me that I'm wrong, because normally I am. So whilst they might fail, they might do that check at when you run the test at compile time, they're still at that interface level.
And actually, it's a fairly good point. The first red failure for your testing is compiling, right? You've got to get the code compiling first. People often seem to think it's like the failing test is the important bit, the actual running code. I think TDD starts at that point where I've written my magical Wonderland code there that doesn't exist yet, and now I've got to get it compiled. And then I'll get the test to fail and then move on.
Yeah.
I think, anyway.
How about tests for collaboration? Have you ever tried writing tests for somebody you're pairing with and then switching and they implement? And have you ever done anything like that?
Yes.
So we did a lot of this at the bootcamp and at work. And so obviously they're like the different, methods, driver, navigator, and over there, like you'd be writing the test and the code. But there are also things like ping pong, which I think is really nice. That's when you write a failing test and then the other developer that you're pairing with passes the test, and then they write a test, and then you pass that test, if that makes sense. And I think it's really interesting because you're almost given that release from not even thinking about how you are going to pass that test. That's kind of the other developer's job. And I really like that about ping pong, because that you could get a completely different answer or like production code from what you had envisioned that you would write for it, and like bouncing off each other in that way. Oh, is that why it's called ping pong? Sorry.
Glad that got recorded.
And yeah, so like bouncing off each other in that way could actually surprise you on how you design your code. So yeah.
I love that. I'd actually never thought of that. That idea that you're free to not worry about how you're going to solve it. All you're focusing on is how you want to use that code. I think that's actually a great point. Yeah.
I'd like to add to that. Another important thing about TD is this idea of iterativeness. So it should be behavior focused, but you should be trying to cut the scope of the thing down to as smaller vertical slice as you can. Because the idea is that we work in a knowledge trade, right? And feedback loops help us improve our knowledge of us what we're doing. So if we tighten those feedback loops and we get faster feedback on what we're doing, we have a better chance of success. And what I like about ping pong thing is like it feels bad if you're holding the keyboard for a long time, or if your colleague is holding the keyboard for a long time. And it kind of brings out that conversation of like, why have I been holding the keyboard for half an hour? This sort of thing should be like, I write a test for like 2-3 minutes, maybe, if that. And then I pass it to my friend and we go back and forth. And if you're not having that sort of fast back and forth, that tells you that you're not thinking about breaking the problem down well enough.
That's interesting.
I just want to quickly add on that as well. I think I remember when I started off on my job for software development, I was actually pairing with Dave, and he did something really good. And that was when we were pairing on something, I think we did the ping pong strategy as well. And if I would write a test, he would actually guide me to write a test that is focused on behavior. Because, so for example, if I said, I expect 1 + 2 to be 3, he would just return the code and say, hey, oh yeah, so this function is going to return 3. And that was like really good in the beginning because, like we learned how to really test behavior rather than the actual output of something. Yeah.
Yeah, I see. So you have an example in your test code and you can just pass that test by cheating.
Yeah.
So maybe then you'll write either a few examples or maybe you do something different. Maybe there's a loop and you do a little 1 to 10 or something like that. So that's quite interesting. Yeah, using Go code and treating test code like it's normal code and seeing how that can impact it. I think that's great. Testing was a first-class concern for Go. Does that make it easier to do TDD, or can you do TDD in any language?
I think it does make the barriers to entry a bit simpler, but I would say, it makes testing easier, right? I suppose if you consider one of the goals of TDD is to help you design, it goes a fairly limited language on purpose, right? It's very simple. There's not a lot of abstraction, power, and all that kind of business. So it reduces the problem space. It reduces the number of possible design solutions for the thing you're solving. So in some respects, it kind of helps you with the design because you're not arguing over abstract classes and monads or whatever. There's a small collection of valid solutions to this particular thing. So in that respect, it kind of makes design easier. But I mean, personally, I don't think it makes that much difference to TDD other than slightly lower barrier to entry, I suppose.
Yeah.
I was just going to say, I was wildly excited when I first met Go, and the testing was in there already. Yeah, it's a wonderful thing, and I think more languages in the future should do the same thing. It's such a good idea.
Yeah, I think they will. I think Ruby on Rails was the first time I saw where it was just there from the beginning, and then, Go has it. And I think that is now a given. I think testing, unit testing, and these capabilities are kind of now it's just a given, isn't it? Because we even had that before we had proper debugger support in Go. So that shows you actually, and I don't use a debugger really. Do you, Chris?
I'd actually like to go back on my statement. I think actually the built-in testing does help with TDD because I like to think that the Go community, because it's so built in and entrenched in language, the community has a culture of testing. Not necessarily TDD, but it has a culture of testing, right? It gets people talking about testing and what we want from testing and things. So actually, I think the fact that it's baked in, it's just a signal to all Go developers, like, go ahead, go write your tests because it's important. And no, I don't use a debugger very much at all. I personally think just writing a failing test or just a test to exercise whatever I was doing with the debugger is a million times simpler. And I can never remember all the keyboard shortcuts to the debugger anyway. It's F10, F9, I don't know. I don't know what step in and step out means. I'm always just confused.
Yeah. Are you a good dancer?
Absolutely not.
There you go. Could be
Yeah, that
linked.
makes sense, yeah.
What about when you're prototyping, when you're just a new thing, brand new, you've no idea what you're going to do. You almost don't even know how you're going to even tackle a problem or even think about it. How do you feel about people that will just do the prototype first and then maybe that gets thrown away and they start TDD? Is that okay? Or would you even write tests in that case?
I have a feeling I'm going to steal what Chris is about to say, and that is
Good.
you would do a spike. I think it's a really useful thing. So if you really have no idea what your requirements are and you don't even know what you're going to build and you just want to try something out, you should do a spike. And that is just writing production code and seeing how, you'd go about it. And then once you get an idea of what you're doing, delete it, but really delete it and start over again through TDD. And you'll almost always come up with a different design to your code and probably a better solution as well. So yeah, I think that's the approach that I've been taught and I agree with.
Yeah, that sounds great. I like what you say about that. Really do disregard it. Don't keep any of it because you don't have the protections that you would have if you'd TDD'd it. Another criticism people talk about with TDD is they think we just don't have time. Like, we don't have time to do this. We've got to get a feature out by Friday. It's urgent. And obviously writing test code and production code is slower, isn't it? As a leading inclination. Intonation.
I mean, I think if we all just, took some time to think about what we do in our lives and our jobs as software developers, is typing at the keyboard, is that really the bottleneck in our lives? Like, generating code, is that like the thing that stopped me getting this thing out into production in this week was the fact that I have like 60 words per minute and not 120? No, right? No, that's not. I mean, don't get me wrong. It's really important to have a loud mechanical keyboard and type quickly, just to absolutely intimidate everybody around you.
Yeah,
But
they got to know you're doing your work.
yeah, it's important. It's great. It's like a great sign. Oh, look, Dave must be doing something. I mean, to be honest, it's when I'm not typing that I'm doing something. It's when I'm sitting there thinking, going, how the hell am I going to fix this? Or how the hell am I going to make this work?
You could do with a mechanical brain so that people could hear that.
If only I had a mechanical brain, it would just rust.
Panto season coming up. We should do it.
Again, the bottleneck's not typing. The bottleneck is not code production. The bottleneck is thinking and understanding and, trying to do the right thing. And that, in terms of a bottleneck, is not going to be made any slower by doing TDD. If you don't know how to do TDD, it will be slower. If you think, the week that I've got crunch time in order to get something out, in order to, not get fired, that is not the time to learn TDD. This is a bad time to learn TDD. Don't start doing TDD that week. But if you do know how to do TDD, it is no slower, and it may be faster, because as I say, it's a thinking tool. It's a way of, leveraging a test in order to think harder about your code and the right way to write it. That's when it might be better and get things done faster. So I very much reject this idea that, oh no, the tests are going to slow me down. I've got to write a load of tests now as well as all the production code. No. You should be writing those tests anyway. I think you should be writing tested code. I think not writing tested code is not a good thing these days. And the second thing is, those tests are a tool to help you get to a good design and a good place if you're doing TDD. So, yeah, please. I don't think it's a slow thing. But if people actually think and, could provide me some evidence that it's the typing that's slowing them down, then good for them. Please don't do TDD. Crack out that code as fast as you can.
Yeah, so I agree with that. I am much faster with TDD than I am without it. Because of that immediate feedback I get, I don't have to kind of imagine and keep it all in my brain. I can just find out the answer by running the test.
Jason Gorman did a little test, he blogged about it, I think, around the Roman numerals kata, where he basically spent one day doing it TDD and then the next day doing it without TDD, and he ping-ponged between the two. Very different solutions each time. Did it over time, and he was faster doing TDD, is essentially what he discovered. Yeah, it's a single sample point, it's slightly biased, he loves TDD, but definitely wasn't any slower.
Yeah.
It's a hard problem, it's hard to think about.
This episode is brought to you by SourceGraph. SourceGraph is universal code search to let you move fast, even in big code bases. Here's CTO and co-founder Byung Lu explaining how SourceGraph helps you to get into that ideal state of flow in coding.
The ideal state of software development is really being in that state of flow. It's that state where all the relevant context and information that you need to build whatever feature or bug that you're focused on building or fixing at the moment, that's all readily available. Now the question is, how do you get into that state where you don't know anything about the code necessarily that you're going to modify? That's where SourceGraph comes in. And so what you do with SourceGraph is you jump into SourceGraph. It provides a single portal into that universal code. You search for the string literal, the pattern, whatever it is you're looking for. You dive right into the specific part of code that you want to understand. And then you have all these code navigation capabilities, jump to definition, find references that work across repository boundaries, that work without having to clone the code to your local machine and set up and mess around with editor config and all that. Everything is just designed to be seamless and to aid in that task of code spelunking or source diving. And once you've acquired that understanding, then you can hop back in your editor, dive right back into that flow state of, hey, all the information I need is readily accessible. Let me just focus on writing the code that implements the feature or fixes the bug that I'm working on.
All right, learn more at sourcegraph.com and also check out their bi-monthly virtual series called DevTool Time, covering all things DevTools at sourcegraph.com/DevToolTime.
Is TDD something that's like, you can sit there in your ivory towers in this academic space where we'd be on podcasts and talk about this is what you should do? What about when you're on the ground? Are there real examples? Do we know? Are people doing this? Is this something that happens?
I don't think TDD is this as rare as people think it is. It's used in banks, in pacemakers, but the most wonderful news I heard was a fine gentleman who worked on some Mars space rocket or something or other, and he said that they did their code with TDD. So not only does it work in the real world on Earth, but it works in another world as well. It is an extremely practical tool for writing software. It's not some strange niche thing. It's actually a very mature technique in terms of the software world. It's not like this thing has been introduced 5 years ago. It's pretty old. There's some really good books on it, and plenty of people are using it successfully.
Yeah, it's brilliant. I love that. I mean, the fact it's on Mars, it's used on robots on Mars. I mean, it can't be that bad, can it? It can get you to Mars. What next for it? What do you think's next for it? Jupiter? That's a real question you have to answer now.
I predict TDD in Alpha Centauri in the next 50 years. There you go. Hopefully, I'll be dead by then. Aliens doing TDD right now somewhere. I bet it. Yeah.
Maybe they would
Who
be.
knows?
Maybe they would be. I actually think they would be. I think if there's any... Yeah, I mean that. I do think aliens would do TDD. I mean, I really do mean that. I'm not trying to be funny. It's a bit like how mathematics, we send prime numbers out, don't we? We transmit to prove intelligent life. We do that with the assumption that they have the same mathematics. I think they'd have if they're going to be writing software, probably, aren't they? If they're advanced enough. I don't know. And I think they'll probably be doing TDD. So send in your tweets and tell us what you think. Do you think aliens are going to be doing TDD? We'd love to hear from you. Are there any gotchas to look out for with TDD? We talked about a couple. Are there any situations where you just wouldn't use that at all, or can it go wrong?
It can definitely go wrong. I think lots of people go wrong with it. And I think, I hope some people listening to this will give TDD a go, and you'll probably find it hard and you'll probably fail at first. It's kind of inevitable. I think what people need to really do is to try and be honest about the quality of their test code at first. The amazing thing about tests is that they're a lens into your code. We've talked about it being viewing the code as a consumer. And a lot of people kind of live with these terrible tests that are horrendous to read and things, and just sort of think that they accept that. And perhaps, again, coming back to this sort of culture of fear of deadlines and things, we haven't got time to refactor the tests, we'll just live with them or whatever. But we should be treating tests as seriously as we do our production code. And if you do that, you start to get insights about your code. We talked about test doubles and mocking earlier. A really easy thing to check with your tests is that, do you have a ton of setup code for your tests, creating a load of mocks and mocking out behavior and things? I think we've all seen tests like this where there's 100 lines of mock setup, and then there are 3 lines of code that are actually interesting. Again, people just kind of live with it, but you need to be asking yourself, what does this mean? Why does this thing have to collaborate with so many things in order to get its job done? That should be ringing alarm bells in your head. Why does this thing have to collaborate? Why is it coupled to so many different things? What happens when we change these things? Obviously, loads of stuff's going to break. So you can use that to guide yourself in terms of helping improve your design. And another trick I like to get people to do is just read your test out loud to a colleague. And it's often harder than you think it is. You think, even when the test is terse, you'll think to yourself, oh, this test looks great. It's only 4 lines of code. This test is brilliant. And then you read it out loud and you're like, I actually have no idea what this test is expressing at all. It's nonsense. And again, it's this idea that tests, they're telling you something. And the beauty of it is that it's this focused lens on a particular part of your system. It's quite hard to appraise lumps of code in your IDE in isolation. You see some function on its own, you go, yeah, sure, that's great, it's just some function. But when you see it being used, that's when you start to understand. So the real pitfalls of TDD really are, one of them is people not looking at their test code and thinking about it properly.
Yeah, I think that's right. You should treat your test code as important, or more important, really, than your program code, right? Because that's another thing that happens is it's very easy to just, I'm going to nip into this project. I'm going to just add another test because I can't be bothered to read all these other tests. I'm just going to add another test. And you can end up with test code that's kind of duplicated in some ways, and it's testing the same thing in different places and things. And that's okay. Sometimes it's probably unavoidable, but you lose the effect of if something does break later, it's quite nice when one test fails and sort of points straight to the thing that's broken, rather than all of your tests failing. Then you still have all your work ahead of you to go and figure out what you've just done. So yeah, I think so. I think treat your test code like it's part of your program code. And that is something that Go does well.
Test code, ideally, should tell you what your code does. And in the beautiful world, it tells you why it does it. But your production code is how. And that's it. That's a reasonable separation to make between the two. I'd like just one more gotcha. Well, there's loads of gotchas. But most favourite ones are people who have already got their design in their heads, and then they want to TDD it. So they go, oh, I've got my design. I know what my API is. I've got all these wonderful methods in my head now. I will now do TDD in order to produce this. And they go, right, here's my method name. And now in the test, I'll write the test for that method and the next method, and just crack through it all. Basically, they could have written the test in one go. They may have written the test in one go. Why not at that point? And, here's the design. And then they wonder why everything is terrible because, they can't change the design or they don't like the design or why even bother doing TDD at that point. And this is, again, the wrong way of doing it. There's two things going wrong here. One of which is you've already thought of the design. Nah. You want to feel the design approach you as you do TDD and then slowly back up into it. Oh, I'm moving backwards in my chair. Couldn't help myself. The test will lead you towards it. It doesn't mean like the test will create it for you, but you'll see what is needed from that design. And the second thing is don't test methods. Never test methods. Well, do test methods because, or functions because there's nothing else to test out there. But you should be trying to test behavior, to encapsulate behavior. Don't just think about this method does this thing. Write something about the behavior in that test. Describe it as well as you can. And that way those tests will last longer and not just be something trashy and throwaway and really coupled and glued into that particular API you built. Anyway, rant over.
No, that's great.
Next time, Dave.
That's great. I like that. So don't write too much test code because that is something that when I started doing it, I would try and just write all my test code for everything that I needed. And in some ways that helps. It can help, like with the design still. And then I set about making that pass. But that's much more difficult than taking it in tiny chunks. Write a piece of it and then make the program code go. How do you do that? Do you tend to kind of keep the progressions small in that way? Or do you write like, here's the complete thing that I know I need? Does it depend?
I think TDD feels right when you are working in those very small steps, and it always feels very safe. Like I think TDD feels right when you write a small test for some kind of important well-defined behavior, and then you make it pass, so you do some refactoring, you do your commit, and then you move on to the next thing. And it should feel like steady progress throughout the day. I think if you start with a test that and when I say test here, I'm saying unit test. If you have a unit test that is going to take you hours to pass, that is when you're not doing TDD right. You haven't really broken the problem down well enough. So I think another kind of sign that you're not doing things right is if that sense of iteration and feedback loop, if that's lost, if you're stuck in the red for a long time, or you're not moving forward, adding new tests, you're just kind of stuck on one test for a long time, that should tell you that you need to rethink your approach a little bit.
That's great.
I have like something small to add there. It's like, I think it's nicer to do it iteratively, like Chris was saying, because I feel like the refactoring stage is such an important bit. When you're writing something and you've, written the production code of it, in the refactoring stage is when you really look at it and you're not even thinking about the tests or anything. You're actually now concentrating. It's like a state of mind and very different to like the second stage where you're just trying to make it pass. Like the third step is, I'm not trying to make it pass anymore. I'm trying to make this, good design. And like when the like patterns start emerging and you start writing, code that is actually good, it could change and evolve differently to when you had written all your test suites, or not test suites, but like test unit tests or whatever beforehand, all in one go. That's what I think.
Yeah, no, that's a very good point. It made me think, do you write test code for the unhappy path, for every possible unhappy path? Like if your code has lots of if error doesn't equal nil return errors, if it has a lot of those in a function, do you try and write test coverage so that you cover each of those cases? Or is there an element of really picking the important bits and trusting yourself on the rest of it? What's your attitude to kind of testing errors? It's a tough one.
Really does depend on the nature of the work you're doing. Generally, if you're not really adding anything, right? So if you're calling something that returns an error and all you do is just, return if error, return error, if you're not doing anything interesting with it, I don't know, I feel like it's not really worth the hassle personally of adding a test for that. But if you're doing something interesting in the error, in other words, if you are adding behavior, right, just because it's working with an error doesn't mean it's not behavior. If you're adding behavior, then that's no different from the happy path, right? You should write some tests around that. And yeah, you might have to faff around with some mocking to make it so the thing fails for you so you can do the test. But again, like when that starts to feel painful again, you can start asking yourself questions around this kind of thing and go, well, is this worth it? Or is there something a bit weird about the design that's making this hard to test? It's difficult to give some concrete advice here. I think it's one of these things where you have to put on your big boy trousers and just think about it for yourself. Do we need to do this? Am I confident? I think another important thing is about confidence, right? Like, if I know that this is going to work and I don't need a test and all the test is doing is just increasing some coverage number, don't worry about that. Like, like this whole obsession over test coverage is nonsense. It's an interesting metric. It can be helpful. Like, if it shows you that a whole particular function isn't tested at all, then yeah, that's useful. But if your boss is telling you to get 90% test coverage, update your CV.
Whoa, brutal. Well, it's that time again. It's time for Unpopular Opinions.
I actually think you should probably leave.
So, do we have any unpopular opinions today?
I mean, all my opinions tend to be unpopular. Yeah. I said we should do this in a pub.
That was not unpopular. Just logistically difficult.
It's just, unpopular with everything else.
Yeah, but it's not logistically difficult opinions, is it? It's unpopular ones.
Think about doing that next time.
I don't know how to get the words into that song.
Get the recording studio, it'd be great.
Yeah.
Yeah, I can throw out an unpopular opinion. Well, maybe it's not unpopular. Maybe
we will test
wrong.
these. We test them on Twitter or the GoTime FM account. We'll tweet them out with a poll and ask people, and we find out. And honestly, most of the time they're not unpopular, but we wonder whether that's just because you put the case so well. So the goal really is to try and get an unpopular opinion where literally more than 50% of people disagree. That's the goal, if you could, Dave.
So, okay, but not something like completely extreme, like Go is terrible. You should do something else. Okay, so I've been around the Go community for a little while, and I think I can think of something that maybe more people will disagree with than agree with. Abstraction is really, really good. There you go. It's not just really, really good, it's your job. Your job is to write abstractions. You may think your job is to write code that works, but basically anybody can write code that works. Your real job is to write code that works and abstract it in a way that means you can build more and better things on top of it. I feel I get the impression from a lot of people in the Go community that abstraction is something to be feared and avoided, that we must never abstract, and that we must write everything in a 1,000-line main function, not method, this is not Java. And that's easier and better in some way because we can now read everything. When I think that's just terrible. I think this is awful advice. You should genuinely be trying to exercise those muscles in your head that lead to good abstractions, good design, because that's what software design is ultimately. It's abstracting, writing functions, writing structs, writing methods. This is all abstraction. And, if you're not very good at it, if you fear writing bad abstractions, well, try to make your code something that can change easily. Design should change. That's a good thing. That's not a bad thing. And also get better at it, because like I say, it's your job. Your job is to write abstractions. It's not just here to write zeros and ones. There's a reason. And, people talk about the standard library being brilliant. The standard library is brilliant. I love the standard library so much. It's got some great abstractions in it. Learn from those abstractions. Use those abstractions. Build upon them. Don't just say, well, we've got this fantastic IO reader here. That's all I need for the rest of my life. I'm done. So that might be my unpopular opinion. Maybe it's popular. I don't know.
Very compelling. Interesting. Yeah. It's funny. I mean, I've definitely kind of advocated for avoiding abstractions until the time is right because, early abstraction, I think, is a sin or can be. But you're right, it kind of depends. And you're also right, like the right abstraction, which is why I think there is a lot of people talking against it, because actually it is the goal. It's the kind of gold. It's gold when you find a good abstraction for something, if you could model that idea in some way, because it is such an enabler, isn't it? It lets other people then kind of work in this way without also and plug in to your work. So that's very interesting. Chris, do you think that's unpopular or what?
I think it might be a little unpopular. I think it's fine for people to have a healthy skepticism to abstractions. Like, yeah, that's fine. Like, I think we've all worked in code bases where, the abstractions are working against you because they're just wrong. And I hope that many people have been lucky enough to write some bad abstraction. I think about the first few years of my career, I was going nuts. I was just doing, I was being overly clever. I was trying to abstract everything, make everything cool, and all this kind of business. And, and it didn't work out all the time. But I wouldn't take that time back because I learned a lot from doing it. And to add to Dave's thing, like my worry is that you need to exercise that muscle. You need to work hard at it and you need to fail before you get good at it. You have to keep practicing and keep trying it out. Coming back to the whole world of TDD and things, like I genuinely feel what's nice about TDD is it gives you a bit of freedom to play around with this kind of business. When I was doing my abstractions in the Stone Age, I didn't have automated tests, so I was just rerunning the application every time and seeing what on earth was happening. So, nowadays, all you kids, you can write tests and get fast feedback. So I agree with Dave's sentiment, but there's a lot of nuance to it, as with everything.
Yeah. How about you, Ria?
No, there's no nuance. Just be angry all the time. That's why I do it. Sorry.
Ria, what do you think about abstractions? What's your take on it currently? Is it something that you strive for? Is it something you avoid?
Well, with my 2 years of experience, yes. I think I'm at that point where I'm just kind of I think I'm just going out there and doing what I think looks good. And in my eyes, when I see a nice abstraction that looks nice, I'm like, yeah, I did a good job. But obviously there are times when it isn't good. And there has been one time though, I remember doing something, and because of abstraction, we saw something and we did the gathering that we call it, and it actually made us put our code back together in a better way. Yeah, I hope I explained that well. But
what's the gathering? It sounds like a horror film.
Maybe Dave and Chris could explain that.
That's all on Chris. I think it sounds like a horror film, but that's me.
Okay, I'll try. A lot of people talk about separation of concerns, right? About trying to pull things apart, to make things small and all that kind of business. But a lot of people miss the cohesion side of this kind of design discussion about how a lot of things that people don't do when they're designing software is finding this bit over here and this bit over here and going, oh, actually, these two things, they're related. Like every time I want to change this behavior, I end up going to this file and this file and this file. And that's happened over and over again. What I should be telling you is that actually these things belong together. They're changing for the same reason. So if you bring them into a cohesive thing, or you do the gathering, then you stand a chance of improving your code.
That was a software pattern that was put together by Stephen King originally, I think. Do we have any other unpopular opinions?
All right, well, I do. I think a lot of people talk about CI and they say they do CI. But when you ask them what their process is, it's not continuous integration, it's continuous isolation. And what I mean by that is CI was invented because the extreme programmers at the time, they realized that a big pain in projects was, this group of developers working over here and this group of developers working over here. But they were working in isolation. And when you try to bring the units together, that's when you cause a lot of problems and a lot of pain. And nowadays, it seems like the default position is to work with pull requests. And they end up suffering these same problems of people working in isolation and not really working together. And when they integrate things, they end up having merge conflicts and all this other kind of hassle. So to sum up the unpopular opinion, I would say if you have a group of trusted developers, like you have a team who work together, I think you should look into trunk-based development because it's far simpler process to work in. And again, coming back to this idea of feedback loops, your feedback loops are way tightened because you're just all working on one branch effectively. I think PRs are great for open source software because you want to welcome contributions from other people and you don't have implicit trust. But presumably you trust your teammates. So you don't need that overhead. You don't need that ceremony. You should just commit to main and get on with your lives.
That's not unpopular with me. That's exactly how I do it. Just push straight into main. Yeah. Nice one.
Only way to live. Only way to live.
Well, unfortunately, that is all the time we have. I feel like we really only sort of scratched the surface of test-driven development and testing generally. If you wanted to learn Go with tests, are there any resources that you could use for that, Chris?
There is a free open source book called Learn Go with Tests, which will both teach you Go and TDD. So yeah, you should go visit it and even contribute. I'm trying to work through the pull requests at the moment, but I do welcome contributions and feedback. Oh, it's also available in Chinese, Portuguese, Korean, possibly Japanese as well, if that's
so if you really want a challenge. Oh, I suppose if you speak those languages already, that'd be useful as well. Yeah. Wow, that's really great. And people have contributed those translations, have they? Because no offense, you don't strike me as intelligent enough to be able to do all that yourself.
No, it's fair. I am a typical British person who just hasn't learned other languages. No, that's I mean, basically what happened was people from, I think the first one was the Brazilian Go community. Some people reached out and said, can we translate this? And I was like, go for it. I'm incredibly flattered that you do that. They're incredibly organized. They actually have a number of people doing it. And I kind of follow the projects. I mean, all the comments are in Portuguese, obviously, and I can't understand it, but it looks cool. It looks like they're doing some good stuff.
Wow, that is so good. I love that happens. And it's great that you chose to do that as a kind of free open source thing for everybody. Because, I've got a book, Go Programming Blueprints, 2nd edition, still available. But people have to pay for that. So I'd really admire that, Chris.
Oh, thank you.
Yeah. I mean that as well, even though I know it sounded sarcastic.
It didn't sound sincere at all. But,
I don't know how to sound sincere.
I get it. It's one of these things where I didn't intend it to be like that at all. I just had some free time. I had a perception that there wasn't a lot of TDD material for Go. So I thought, well, I'll just make a Hello World tutorial on TDD. And it just kind of blew up. And I think if there's one thing I'd say to the listeners is if you like a project, tell the person that you like it, because it's such a motivator. There's no way I would have written all that stuff if I hadn't had such warm feedback about it. I would have stopped at Hello World. But people telling me they'd help them and they understand TD a bit better, all that kind of stuff. It makes my day when I hear that kind of stuff. So if you enjoy someone's project, just reach out to them and tell them.
That's lovely. And Ria, also, thank you for the work you do helping people. It's great. One of the things I love about the Go community is that we do encourage kind of diversity where other communities don't. And we get the benefit of it. So that's the thing. Our lives are all richer for it. So thank you. And I know it's not easy. It takes a lot of effort. So that's great. Dave, do you do anything nice, mate?
No. I one of my unpopular opinions might be about my 2.5-year-old daughter, who basically soaks all the time out of my life and gave me 1.5 hours sleep last night.
Oh,
so
that's generous.
If I'm in any way incoherent and angry, it's mainly her. Who I love. I love my daughter, sorry. God, this is going to be recorded and she's going to listen to this when she's like 12 or something. Oh, man.
Yeah, 12-year-olds love this. 12-year-olds love this podcast.
Yeah. It should be a Go program, I can tell.
Oh, yeah.
Gonna get all the plushies.
Oh, yeah. Well, thank you so much. And thanks, everyone, for listening. This has been great. Chris, Dave, Ria, thank you so much. You'll have to come back anytime. We'd love to have you. And we'll see you next time on Go Time. Bye.
Bye. Bye. Thank you, Matt.
Thanks for listening to this episode of Go Time. If this is your first time with us, subscribe now at gotime.fm or in your favorite podcast app. Just search for Go Time. You'll find us. And if you enjoy the show, please send it to a friend or a colleague who might also enjoy it. We truly appreciate it. Go Time is produced by Jared Santo with music by Breakmaster Cylinder. We're brought to you by Fastly, Launch Darkly, and Linode. Next time on Go Time, Dave Cheney returns, and this time he has Mickey Tebeka by his side. The topic, Learning Go with pop quizzes. That episode will be hitting your podcast feed next week.